Tonight, we follow the story of the Milky Way, a vast river of stars flowing silently through the universe. Welcome to the Orbit for Sleep channel. Let us follow the orbit of science and drift gently towards sleep. The Milky Way is the galaxy we live in. A galaxy is a massive collection of stars, gas, dust, and invisible matter, all held together by gravity. You can imagine it as a giant cosmic city, and every star inside it is like a building with its own story. Our sun is just one of those stars, one small home within this enormous city of light. The Milky Way contains hundreds of billions of stars. If you tried to count them one by one, even counting one star every second, it would take thousands of years to finish. Most of these stars are too far away or too faint for us to see, but together they form the soft band of light that stretches gently across the night sky. When we look up at a clear night sky, far from city lights, we see a pale, milky ribbon of light. This is where the name Milky Way comes from. Long before telescopes existed, people from many cultures described it as a river of milk, a path of spirits, or a bridge of the gods. Today, science tells us that this glow comes from the combined light of countless distant stars. The Milky Way has a spiral shape. If we could step far outside the galaxy and look at it from above, it would look like a spinning pinwheel, with long arms curving outward. However, we cannot see this shape directly from the outside because we live inside the galaxy. It is like trying to understand the shape of a forest while standing among the trees. We can see the beauty around us, but the full shape is harder to notice. Even though the Milky Way looks calm and still from Earth, it is full of motion. Stars orbit the center of the galaxy, drifting quietly through space like leaves carried by a slow, endless current. Our sun is also moving, making a long journey around the galaxy that takes about 230 million years to complete. The Milky Way is not alone. It is just one galaxy among trillions in the universe. Each galaxy has its own stars, planets, and cosmic history. Yet for us, the Milky Way is home. It is the vast cosmic neighborhood where our story begins. As we continue, we will explore the size of the Milky Way, its structure, and where exactly we are located within this grand, silent swirl of stars. The Milky Way is remarkably large, especially when compared with what we can see in the night sky. Even though it appears as a thin band of light to our eyes, it is a full galaxy stretching across space. The Milky Way is about 100,000 light-years wide. 1 light-year is the distance light travels in 1 year, which is almost 9.5 trillion kilometers. This means that if we could travel at the speed of light, it would still take 100,000 years to cross our galaxy from one end to the other. To understand this size more simply, imagine shrinking the entire Milky Way to the size of a large dinner plate. At this scale, our entire solar system would be smaller than a grain of dust resting on the plate. This helps us see how tiny our cosmic neighborhood is compared to the full galaxy. The Milky Way contains around 200 to 400 billion stars. This number is not exact because we cannot count each star directly. Dust and distance hide many of them. Still, astronomers estimate this range by studying the brightness and patterns of the stars we can observe. When you look at the sky, you can see only a few thousand stars with your eyes, but the Milky Way holds hundreds of billions more. Not all galaxies are the same size. The Milky Way is considered a large galaxy, but it is not the biggest. There are galaxies smaller than ours, called dwarf galaxies, which can contain only a few million stars. On the other hand, there are giant galaxies, such as some found in galaxy clusters, that hold trillions of stars. Compared to them, the Milky Way is large but still modest. One of the most famous galaxies to compare with our own is the Andromeda Galaxy. Andromeda is the closest large galaxy to us, located about 2.5 million light-years away. It is bigger than the Milky Way, stretching roughly 120,000 to 150,000 light-years across and holding about 1 trillion stars. If the Milky Way and Andromeda were two cities, Andromeda would be the larger and brighter one. Even though these distances seem unimaginably large, space is mostly empty. Stars within a galaxy are spaced very far apart from each other. If our solar system were the size of a coin, the next nearest star, Proxima Centauri, would be another coin placed several kilometers away. This distance gives galaxies their calm, spacious appearance. The Milky Way is part of a small group of galaxies called the Local Group. This group includes more than 50 galaxies, many of them small dwarfs orbiting the larger ones. Within this group, the Milky Way and Andromeda are the two dominant members, each with their own families of smaller galaxies. Thinking about the size of the Milky Way reminds us of how small we are in the universe. We are living within a galaxy that is enormous in scale, yet only one among countless others in the cosmos. As we continue, we will explore where exactly we are located inside this vast, spiral structure. Our solar system has a specific home inside the Milky Way, and understanding where we are helps us see our place in the galaxy more clearly. The Milky Way is a spiral galaxy with long, curved arms that extend outward from the center. These arms are made of stars, gas, and dust, and they slowly rotate like gentle waves frozen in time. We are not located at the center of the Milky Way. The center is a crowded and energetic region filled with stars, dust, and a supermassive black hole. If our solar system were there, the night sky would be extremely bright. Instead, our solar system sits far away from the center, in a quieter and calmer part of the galaxy. Our home is on one of the spiral arms called the Orion Arm, or the Orion Spur. It is a small branch located between two larger arms known as the Sagittarius Arm and the Perseus Arm. The Orion Arm is like a peaceful suburb within a vast cosmic city, not too loud, not too bright, just right for life to grow and evolve. We are about 27,000 light-years away from the galactic center. This means that even traveling at the speed of light, it would take 27,000 years to reach the middle of our galaxy. The distance gives us a safe and stable environment, far from the intense radiation and gravitational activity found near the center. If we look at the shape of the Milky Way from above, our solar system would be somewhere along one of the curved arms, slowly circling the center. Scientists estimate that the Sun takes around 230 million years to complete one full orbit around the galaxy. This long journey is often called the galactic year. Since the Sun formed, it has only completed about 20 to 25 of these galactic years. The area around our solar system is filled with stars, but they are spaced very far apart. Even our closest neighboring star system, Alpha Centauri, is more than 4 light-years away. This distance is one reason the night sky appears calm and clear. We can see the stars around us because they are not too crowded. Our position in the galaxy has played an important role in Earth's history. Being in a quieter region has allowed life to survive without constant cosmic disruptions. If we live closer to the center or in a more active part of a spiral arm, the conditions might have been too unstable for complex life to form. Knowing where we live in the Milky Way gives us perspective. We occupy a small, peaceful corner of a massive galaxy. In the grand structure of the Milky Way, our solar system is just a tiny point of light, but it is a place full of stories, life, and possibility. As we continue, we will explore how the Milky Way came to be and how it has changed over time. The Milky Way did not appear suddenly. It formed over a very long period of time through a series of cosmic events that shaped it into the galaxy we know today. Scientists believe that the Milky Way began to take shape more than 13 billion years ago, not long after the universe itself was born. In the early universe, matter was spread out in clouds of gas, mainly hydrogen and helium. Over time, gravity pulled these clouds together, forming the first stars and small clusters of stars. These small clusters later merged with one another, slowly growing into larger structures. The Milky Way is the result of many of these mergers, where smaller galaxies came together to build a bigger and stronger one. The Milky Way's oldest stars are found in regions called globular clusters. These are dense, spherical groups of stars that orbit around the galaxy like tiny satellites. Some of these stars are more than 12 billion years old, making them among the oldest stars we can observe. They act as ancient storytellers, holding clues about the galaxy's earliest days. As time passed, more gas and dust collected, forming new stars and creating the spiral shape we see today. The formation of the spiral arms was not instant. It developed gradually as stars and gas moved under the influence of gravity. These arms are not solid structures. They are more like waves where stars are slightly more concentrated. New stars often form within these arms. The Milky Way has grown not only by forming stars but also by absorbing smaller galaxies. Even now, the galaxy continues to change. Astronomers have discovered streams of stars across the sky, remnants of smaller galaxies that the Milky Way has pulled apart and absorbed over time. This process is still ongoing. One of the most important events in the Milky Way's history was the formation of the solar system, about 4.6 billion years ago. Our sun formed from a cloud of gas and dust that collapsed under gravity. Nearby stars may have exploded as supernovae around that time, spreading heavy elements into space. These elements helped form planets, moons, and eventually life. The Milky Way is not finished evolving. It continues to move, grow, and interact with nearby galaxies. Its shape, population of stars, and structure are still changing, even if we cannot see it happen in our lifetimes. From the quiet night sky, the Milky Way may look peaceful and unchanging, but on a cosmic scale, it is full of motion and transformation. Understanding how the Milky Way formed gives us a deeper sense of connection to the universe. We are living inside a galaxy shaped by ancient stars, cosmic collisions, and billions of years of change. As we move forward, we will explore why the Milky Way appears as a bright, milky band across our sky and what gives it its familiar, dreamlike glow. When we look at the night sky on a clear, dark night, we see a soft, glowing band of light stretching across the sky. This gentle, milky ribbon is what we call the Milky Way. The reason it looks like a river of stars is because we are looking through the densest part of our galaxy from the inside. The Milky Way is shaped like a flat spiral disk. Our solar system lies within this disk, not above or below it. When we look toward the plane of the galaxy, the direction where most of the stars are located, we see millions of stars packed together. From Earth, their combined light blends into a smooth glow, rather than appearing as individual points. If we were to look at a region of the sky away from the plane of the galaxy, we would see fewer stars. The sky would look darker and emptier in comparison. This difference in star concentration is what creates the long, hazy band across the night sky. The Milky Way appears white and misty to the human eye because the light from distant stars is very faint. Our eyes cannot separate each star clearly, especially at night. Instead, the light appears like a pale cloud. With a telescope or long-exposure camera, that same band reveals countless stars, glowing nebulae, and dark dust lanes. These dark lanes are made of cosmic dust, tiny solid particles floating in space. Dust blocks the light behind it, creating patterns that look like cracks or shadows across the Milky Way. Rather than being empty, these dark regions are full of material that can eventually form new stars. Different seasons offer different views of the Milky Way. In some months, we see the brighter central part of the galaxy, which appears thicker and more detailed. In other months, we see the outer regions, where the band looks thinner and softer. This change happens because Earth orbits the Sun, and our nighttime view shifts slightly throughout the year. Before city lights became common, people around the world watched the Milky Way with wonder. To many ancient cultures, it looked like a river in the sky, a path for spirits, or a bridge connecting worlds. Although science now explains the Milky Way through physics and astronomy, the sight still feels poetic and peaceful. If we could leave Earth and travel far above the galaxy, the Milky Way would no longer look like a ribbon. Instead, we would see its full spiral shape. The River of Stars appearance is a result of our position inside the galaxy, looking along the dense, star-filled plane. Seeing the Milky Way reminds us that we are part of something vast. That soft band of light is made of billions of stars, stretching across space and time. As we continue, we will move beyond simple appearance and explore the inner structures that shape our galaxy. The Milky Way is shaped like a spiral, and one of the most striking features of this shape is its spiral arms. These arms are long, curved regions that wind gently around the center of the galaxy. They are not solid structures, but rather patterns where stars, gas, and dust are slightly more concentrated, creating a graceful, flowing shape that slowly rotates over time. Our galaxy has several major spiral arms, along with smaller branches. The two largest arms are known as the Perseus arm and the Scutum Centaurus arm. Between them lie smaller arms and spurs, like the Orion arm, our home. You can imagine the galaxy as a giant spinning wheel, and these arms as the soft, glowing trails left behind as it turns. Spiral arms are important because they are regions where many new stars are born. The gas and dust within these arms are gently compressed as they move through the galaxy, creating the right conditions for star formation. Young stars shine brightly, giving the arms their luminous appearance. It is as if the galaxy is decorating its arms with fresh, bright lights as time passes. The arms move at different speeds depending on their distance from the center. Stars do not stay fixed within one arm forever. Instead, they drift in and out over millions of years. A spiral arm is more like a traffic pattern on a highway than a solid structure. Cars come and go, yet the traffic jam itself can stay in one place. In the same way, stars enter and leave the spiral arms, but the arms themselves remain. If we could float above the Milky Way and watch it from a distance, the spiral arms would appear like long, delicate brushstrokes on a dark canvas. They would slowly turn, carrying stars gently along their curved paths. The motion is so slow that even after a lifetime on Earth, we would not notice the change. Despite their beauty, spiral arms are affected by powerful forces. Gravity shapes the arms, while the movement of stars, gas, and dark matter influences their form. The arms are also connected to the galaxy's rotation, which helps maintain their overall structure, even as individual stars move in and out. Our own solar system is currently located in the Orion Arm, a small branch between the major arms. This quiet position gives us a comfortable view of both nearby stars and the darker spaces in between. If we lived in one of the major arms, the night sky would appear more crowded, filled with brighter stars and more cosmic clouds. Understanding the spiral arms helps us picture the Milky Way as a living, dynamic system. It is not a frozen map of stars, but a gentle, flowing pattern that continues to evolve. As we move forward, we will explore the center of the Milky Way, where the calm motion of the arms gives way to a far more energetic and mysterious region. At the heart of the Milky Way lies a region very different from the calm space around our solar system. This area is known as the galactic center. It is a crowded, energetic, and mysterious place filled with stars, gas, dust, and powerful forces. If we could travel there, the night sky would appear far brighter than it does on Earth, glowing with countless stars packed closely together. One of the most remarkable features of the galactic center is a supermassive black hole called Sagittarius A stars. A black hole is a region of space where gravity is so strong that nothing, not even light, can escape. A supermassive black hole is millions of times more massive than our Sun. Sagittarius A stars is about 4 million times the mass of the Sun, yet it is compact, fitting into a space smaller than our solar system. We cannot see Sagittarius A star directly because black holes do not give off light. Instead, astronomers observe the stars and gas around it. By watching how stars move near the center of the galaxy, scientists discovered that something extremely massive must be pulling them with strong gravity. Their motion revealed the presence of the black hole long before we could capture an image of it. In 2022, the first image of Sagittarius A asterisk was released. It did not show the black hole itself, but rather the glowing ring of gas surrounding it. As gas and dust fall toward the black hole, they heat up and emit light, creating a bright halo-like shape. The dark center of the image marks the area where light cannot escape. The galactic center is full of activity. Stars are packed tightly together, and many are larger, hotter, and shorter-lived than the Sun. Powerful winds, radiation, and energetic events shape this region. Clouds of gas swirl around the black hole, sometimes forming new stars. The environment is intense, busy, and always changing. Although the center of the Milky Way sounds dangerous, our solar system is located far enough away, about 27,000 light-years, to avoid these harsh conditions. This great distance keeps life on Earth safe from the strong radiation and gravitational effects near the black hole. If we could look toward the galactic center from Earth with perfect clarity, we would see a bright, golden glow shining through the darkness of space. However, thick clouds of cosmic dust block much of the light, making the center appear dim to the human eye. Special telescopes that detect infrared and radio waves allow scientists to see through the dust and study this hidden region. The presence of a supermassive black hole at the center of a galaxy is not unusual. Many large galaxies contain one. Scientists believe that black holes and galaxies grow together over billions of years, shaping each other in complex ways. The galactic center reminds us that the Milky Way is not just a silent swirl of stars. Beneath its calm appearance lies a powerful core full of movement and energy. As we continue, we will explore how stars form within the Milky Way and how the galaxy continues to create new sources of light over time. Stars are not eternal. They are born, they live, and eventually they reach an end. In the Milky Way, star birth happens in calm but active regions known as stellar nurseries. These are large clouds of gas and dust, called nebulae. A nebula may look like a faint mist through a telescope, but it is filled with the raw material needed to create new stars. A star begins to form when part of a nebula becomes denser than the surrounding area. Gravity pulls the gas and dust closer together, slowly shaping a small, compact core. As the core becomes tighter, it heats up. Over thousands to millions of years, the temperature rises until the center becomes hot enough for nuclear fusion to begin. Nuclear fusion is the process that powers stars. It happens when atoms of hydrogen are pressed together so tightly that they join to form helium. This reaction releases an enormous amount of energy, producing light and heat. When fusion begins, a new star is born. Not all stars are the same. Some stars form as small, cool, red stars that burn slowly and quietly. Others become large, bright, and hot blue stars that shine with great intensity but live much shorter lives. The size of a star depends on how much material the nebula provides during its formation. Stellar nurseries are scattered throughout the Milky Way, especially in the spiral arms. These regions are rich in gas and dust, making them ideal for star formation. When new stars form, they often create clusters, groups of stars born from the same cloud. Over time, some of these stars drift apart, while others remain together in open star clusters. Young stars can have a remarkable effect on the clouds they come from. Their light and strong winds of charged particles push away the surrounding gas and dust, shaping the nebula into new forms. This process can trigger the birth of even more stars nearby, continuing the cycle. Our own sun was once born in a stellar nursery about 4.6 billion years ago. It likely formed along with many other stars. Over time, the sun drifted away from its original cluster, leaving us without any clear sibling stars today. The birth of stars is a quiet but powerful process. It shapes the appearance of the Milky Way, fills it with light, and creates the environments where planets can eventually form. Every star in the night sky is a reminder of the long cosmic journey from a cold cloud of gas to a shining beacon of light. As we move forward, we will explore the hidden material that surrounds our galaxy, the dark matter that shapes the Milky Way in ways we cannot see but can measure through its influence. The Milky Way, with all its stars, planets, gas, and dust, is only partly visible. A large portion of the galaxy is made of something we cannot see at all: dark matter. Dark matter does not give off light, reflect light, or interact with light in any way. It is invisible, yet it plays a crucial role in holding the galaxy together. Scientists discovered the presence of dark matter by studying how stars move within the galaxy. Stars far from the center were moving faster than expected. If only visible matter were present, those stars would not have enough gravity to stay in orbit. They would drift away into space. Something unseen had to be providing extra gravity, and that invisible mass is what we call dark matter. Dark matter forms a large spherical structure around the Milky Way called a halo. A halo is like a protective bubble of gravity that surrounds the entire galaxy. It extends far beyond the spiral arms, reaching well outside the visible disk of stars. If we could see the dark matter halo, it would make the Milky Way look much larger and more rounded than the thin, starry disk we see in images. Even though we call it dark, dark matter is not the same as empty space. It has mass, meaning it adds weight to the galaxy. This mass creates the gravity that holds everything together. Without dark matter, the Milky Way could not maintain its shape. The stars would slowly drift apart instead of moving together in a graceful spiral. Scientists do not yet know what dark matter is made of. It is not like normal matter, which is built from atoms. Dark matter may be made of particles that we have not yet detected. Many theories exist, and scientists continue to search for clues using telescopes, detectors deep underground, and observations of galaxies across the universe. Even though we cannot see dark matter directly, we can observe its effects. One way is through gravitational lensing, a phenomenon where the gravity of dark matter bends the light from distant galaxies. This bending acts like a cosmic magnifying glass, revealing where dark matter is located. The dark matter halo also influences how galaxies form. It provides a kind of gravitational framework that gathers gas and dust, helping galaxies grow. The Milky Way formed within a dark matter halo, and the halo still shapes its behavior and movement today. For us on Earth, dark matter does not cause any harm. It passes through us without interaction, like a silent guest we cannot feel. Its presence is gentle, steady, and constant, providing the invisible support that holds our galaxy together. Knowing that most of the Milky Way is made of something unseen reminds us of how much there is still to learn. The universe is full of mysteries that lie just beyond our senses. As we continue, we will explore another hidden but beautiful ingredient of the galaxy, the cosmic dust and nebulae that paint our night sky with color and light. The Milky Way is filled with more than just stars. Scattered throughout the galaxy are clouds of gas and dust that shape its appearance and play a key role in how it changes over time. These materials may seem small and quiet, but they help create new stars, color the galaxy, and add texture to the night sky. Cosmic dust is made of tiny solid particles. Each grain is smaller than a speck of smoke, yet billions of these grains float through space. Though small, dust can block and scatter light, creating dark patches that look like gentle brushstrokes on the Milky Way. When we see dark lanes across the glowing band of the galaxy, we are seeing dust clouds drifting between us and distant stars. Gas in the Milky Way exists mostly as hydrogen and helium. It spreads across space in large clouds, sometimes thin and quiet, and sometimes dense and active. When gas and dust gather together in certain regions, they form nebulae, vast, colorful clouds that can stretch for light years. Nebulae are among the most beautiful sights in the galaxy, though most are too faint to see with the naked eye. There are different types of nebulae, each with a unique role. Emission nebulae glow with light because young, hot stars energize the gas around them. Reflection nebulae do not produce light themselves but shine softly by reflecting the light of nearby stars. Dark nebulae are dense clouds that block light completely, forming deep shadows against bright regions of space. Planetary nebulae are shells of gas left behind when dying stars release their outer layers. Together, dust and nebulae act like the paint and canvas of the galaxy. They create patterns, shapes, and colors that make the Milky Way visually rich. If we could look at our galaxy from outside, we would see bright swirls, glowing clouds, and dark streaks woven throughout the spiral arms. Although gas and dust add beauty to the galaxy, they also have an important purpose. These materials are the building blocks of stars and planets. Over millions of years, gravity gathers dust and gas into denser regions. When enough material collects, a new star can form. Some of the leftover material may become planets, moons, or asteroids. Cosmic dust also carries elements created by older stars. When a star ends its life in a supernova, it spreads heavy elements into space. These elements eventually mix with dust and gas, enriching the galaxy and allowing new planets and life to form. In this way, dust holds the history of earlier generations of stars. Even though dust and nebulae are essential, they can make it harder for us to see the Milky Way clearly. They hide distant stars and block our view of the galactic center. Scientists use special telescopes that detect infrared and radio waves to look through the dust and study the hidden regions of the galaxy. The dust and clouds of the Milky Way remind us that space is not empty. The galaxy is alive with movement, creation, and transformation. As we continue, we will step beyond the galaxy itself and explore how its story connects with the existence of Earth and the life that grew here. Life on Earth did not appear by chance alone. The Milky Way itself created the conditions that made our planet and all living things possible. From the elements in our bodies to the calm environment that allowed life to grow, the galaxy played a quiet but essential role. The story begins with stars. The first generation of stars in the Milky Way contained only simple elements like hydrogen and helium. Over time, these stars aged and exploded as supernovae, releasing heavier elements into space. These elements include carbon, oxygen, nitrogen, iron, and many others. They spread through the galaxy, becoming part of new clouds of gas and dust. Our Sun and Earth formed from one of these enriched clouds about 4.6 billion years ago. The materials that once belonged to older stars became the building blocks of our solar system. The iron in our blood, the calcium in our bones, and the oxygen we breathe were all created inside ancient stars. In this way, we are connected to the Milky Way not just by location, but by origin. The Milky Way also provided a stable environment for life to develop. Our solar system is located in the Orion Arm, a relatively calm region of the galaxy. This position keeps us far from dangerous areas near the galactic center, where intense radiation and powerful gravitational forces could disrupt life. Even within the Orion Arm, we live in what scientists sometimes call the galactic habitable zone. This is a region where conditions are neither too chaotic nor too quiet. There are enough heavy elements to form planets, but not so much radiation or frequent star explosions that life would struggle to survive. Earth benefits from this balance. The Milky Way's spiral structure also plays a role in protecting life. As stars travel through the galaxy, they pass in and out of the spiral arms. These arms contain many young, energetic stars that can produce harmful radiation. Fortunately, our solar system currently sits between major arms in a safer zone with fewer risks. Life on Earth has experienced challenges from cosmic events, such as nearby supernova explosions or shifts in the solar system's orbit. Yet overall, the Milky Way has offered long periods of stability, allowing simple organisms to evolve into complex life forms, eventually leading to humans. The galaxy continues to shape life on Earth today. Cosmic rays, the motion of the solar system, and the distribution of stars all influence our environment in subtle ways. Though these effects are small, they remind us that Earth is not isolated. It is part of a much larger system. Knowing that the Milky Way helped create and protect life gives a sense of connection to the universe. We are made of the same materials that shine in the night sky. As we continue, we will explore the Sun's long journey through the Milky Way and how this cosmic path influences our place in the galaxy. The Sun is not standing still in space. It is on a long and gentle journey around the Milky Way, carrying Earth and the rest of the solar system with it. This path is called the galactic orbit, and it shapes our place in the galaxy over millions of years. The Milky Way's gravity pulls the Sun into a wide circle around the galactic center. The distance from the Sun to the center of the galaxy is about 27,000 light-years. Even at this great distance, the Sun is still influenced by the strong gravity of the Milky Way's core, which keeps it moving along its orbit. The Sun travels at an impressive speed, about 220 kilometers per second. Even at this speed, one full orbit around the galaxy takes around 230 million years. This long journey is sometimes called a galactic year. Since the Sun formed about 4.6 billion years ago, it has only completed around 20 of these galactic years. During this orbit, the Sun does not follow a perfect circle. Its path gently rises above and dips below the galaxy's disk, like a slow wave. Scientists believe this vertical motion may influence conditions on Earth, although the effects are subtle and unfold over long periods of time. The Sun's journey also means that Earth sees different parts of the galaxy over time. Sometimes we are closer to a spiral arm, where more stars and cosmic activity are present. Other times we travel through quieter regions between the arms. Our current position between major arms provides a relatively calm environment for life. The solar system moves through an area of space influenced by nearby stars and interstellar clouds. Occasionally, we pass near regions of dust or gas, though not close enough to cause harm. These encounters are rare on a human timescale but natural over millions of years. The Sun is not alone on its journey. Billions of stars orbit the galaxy alongside us, each with its own path and speed. From a distant viewpoint, the Milky Way would look like a graceful dance, with countless stars moving around the center in a coordinated flow. Despite this constant motion, we do not feel it on Earth. Our planet moves smoothly with the Sun, and the journey through space is silent. If we could look back on the path the Sun has traveled, it would appear as a long, gentle curve stretching through the galaxy, a trail of time and light. Understanding the sun's galactic orbit reminds us that our home is not fixed. We are travelers through the Milky Way, carried across the galaxy on a slow and peaceful voyage. As we continue, we will explore how the Milky Way has shaped human culture and imagination throughout history, long before we understood the science behind it. The Milky Way has been part of human life for as long as people have looked up at the night sky. Long before telescopes and modern science, our ancestors saw the soft band of light stretching overhead and felt a sense of wonder. The galaxy shaped the way people understood the world, guided travel, and inspired stories that continue to live today. On a clear night, far from city lights, the Milky Way appears as a pale, glowing river across the sky. This sight has influenced cultures around the world. Many ancient civilizations believed the Milky Way was a pathway or bridge between the earthly world and the heavens. To them, it was not just a collection of stars, but a connection to something greater. In many cultures, the Milky Way was seen as a road for spirits. Some believed that souls traveled along this shining path after death. In others, it was thought to be a river of stars flowing across the sky, carrying messages from the gods. These stories gave meaning to the night sky and offered comfort, guidance, and imagination. The Milky Way also played a practical role in navigation. Before compasses and maps, travelers used the stars to find their way. The shape and position of the Milky Way helped guide people across land and sea. In the southern hemisphere, for example, many indigenous communities used the dark patches within the Milky Way to mark seasons and navigate. Artists, poets, and philosophers have long been inspired by the galaxy. Paintings, songs, and poems describe the Milky Way as a symbol of beauty, mystery, and endless possibility. Even today, many people feel a sense of calm when looking at the sky, as if the galaxy invites us to pause and reflect. Modern science has changed how we understand the Milky Way, but it has not taken away its sense of wonder. Knowing that it is a galaxy made of billions of stars only adds to the awe. We now see that the faint glow in the sky is not a single object, but the combined light of distant suns, each with its own story. Light pollution has made the Milky Way harder to see in many places. Bright city lights wash out the gentle glow, hiding the stars from view. Some people grow up without ever seeing the Milky Way clearly. This loss has encouraged movements to protect dark skies, so future generations can experience the night as our ancestors once did. When we look at the Milky Way today, we connect with the past. We share the same view that people saw thousands of years ago, even if our understanding has grown. The galaxy continues to inspire curiosity, art, and reflection. As we move forward, we will explore how ancient civilizations told stories about the Milky Way and how those stories reflect the way humans have always searched for meaning in the stars. For thousands of years, people across the world have looked at the Milky Way and created stories to explain its soft glow. These myths reveal how ancient civilizations understood the universe and how they found meaning in the night sky long before science could describe it. In ancient Greece, the Milky Way was linked to the gods. One story tells of the baby Heracles, who drank milk from the goddess Hera. When he suckled too strongly, a stream of milk spilled across the heavens, creating the Milky Way. The name Milky Way comes from the Greek word galaxias, meaning milky circle. To the Greeks, the sky was a canvas touched by the gods, and the Milky Way was one of their marks. In Roman mythology, the story was similar. The Milky Way was seen as a trail of divine milk, a symbol of strength and immortality. The idea connected the stars to the gods and to the gift of life. In East Asia, different cultures created their own stories. In China and Korea, one of the most famous legends is the story of the Weaver Girl and the cowherd. The Milky Way was seen as a river in the sky, called the Silver River, or Jenga. The two lovers, represented by the stars Vega and Altair, were separated by this celestial river and allowed to meet only once a year. The story reflects themes of love, distance, and fate. Indigenous peoples also created rich interpretations of the Milky Way. Many Native American tribes saw it as a path for spirits. Some believed it was the route taken by souls traveling to the afterlife. Others saw it as the campfires of ancient ancestors, glowing softly across the night. In Australia, Aboriginal cultures saw the Milky Way in a completely different way. Rather than focusing on the bright stars, they paid attention to the dark shapes formed by cosmic dust. One well-known figure is the emu in the sky, a dark silhouette formed by dust lanes across the Milky Way. This story was connected to seasons, behavior of animals, and cultural traditions. In parts of Africa, people viewed the Milky Way as a trail of ash or a spilled bag of stars stretched across the sky. Among the San people of southern Africa, it was believed that a girl threw burning embers into the air, creating a glowing path to help hunters and travelers find their way in the darkness. Across Europe, Asia, Africa, and the Americas, many cultures imagine the Milky Way as a road, river, or bridge linking the earthly world to something beyond. These stories help people make sense of life, death, love, and the unknown. Though the details of each myth are different, they share a common theme. The Milky Way connected humans with the universe. It offered explanations, comfort, and imagination. Even today, when we understand the Milky Way through science, these stories remind us of the deep relationship people have always had with the night sky. As we continue, we will explore how cosmic events in the galaxy can influence life on Earth, a reminder that the story of the Milky Way is not only about the past, but also about our future. The Milky Way is a mostly calm home for our solar system, but the galaxy is not completely free of danger. Over long periods of time, certain cosmic events could influence Earth's environment and the future of life. These events unfold slowly on a cosmic scale, far beyond a human lifetime, yet they remind us that Earth is part of a larger, changing universe. One such event is a nearby supernova. A supernova occurs when a massive star reaches the end of its life and explodes. This explosion releases powerful radiation and energetic particles into space. If a supernova happened very close to Earth, it could damage our atmosphere and affect life. Fortunately, there are no stars near the solar system that are likely to explode soon. The closest star that might become a supernova, called Betelgeuse, is far enough away that it would not harm Earth. Another event is the solar system's passage through different regions of the Milky Way. As the sun travels around the galaxy, it moves through areas with varying amounts of dust, gas, and cosmic rays. In regions with more cosmic activity, Earth may experience small changes in climate or radiation levels. These changes happen slowly over millions of years and are not sudden or violent. Occasionally, the solar system may pass near a dense cloud of gas or dust. If this cloud were thick enough, it could partially block sunlight reaching Earth. This could affect the climate, but such encounters are extremely rare. The galaxy is spacious, and the sun usually travels through empty regions with few hazards. There is also the possibility of gravitational interactions with nearby stars. As stars move within the Milky Way, one could pass close to the solar system. A close encounter might disturb the outer region of our solar system, known as the Oort cloud, where icy objects are stored. This disturbance could send comets toward the inner solar system. While such events could increase the number of comets near Earth, close star encounters are uncommon and occur on timescales of many millions of years. On a much longer timescale, the Milky Way itself is moving toward a major change. In the distant future, about 4 billion years from now, our galaxy is expected to merge with the Andromeda Galaxy. Although this may sound dramatic, the vast space between stars means that direct collisions between stars are unlikely. The night sky would gradually change, and the shape of the galaxy would transform. But life on Earth, if it still exists, would not experience sudden destruction from this process. These cosmic events remind us that Earth's story is connected to the Milky Way. The galaxy has offered stability for billions of years, allowing life to grow and evolve. While the future holds changes, they unfold slowly, giving nature time to adapt. Understanding these events helps us see our place in the universe with balance. We are protected by distance, time, and the calm region of the galaxy we inhabit. As we move into the next part of our journey, we will explore the future of the Milky Way itself and the grand cosmic scale in which our galaxy lives.
The Milky Way is not a stationary island in space. It is moving, drifting through the universe, and on a long journey toward a remarkable event. In the distant future, the Milky Way will collide and merge with the Andromeda Galaxy, our closest large galactic neighbor. This event will reshape both galaxies and create a new one in their place. Andromeda is currently about 2.5 million light-years away from the Milky Way. Although this distance is vast, the galaxy is moving toward us at a speed of about 110 kilometers per second. This motion is slow on a human scale, but steady on a cosmic one. Over billions of years, the two galaxies will be drawn together by gravity. The collision is expected to begin around 4 billion years from now. When people hear the word collision, they often imagine stars crashing into each other. However, galaxies are made mostly of empty space. The stars inside them are so far apart that direct star collisions will be extremely rare. Instead, the two galaxies will pass through each other, their shapes stretching and swirling as gravity pulls them into new forms. As the Milky Way and Andromeda interact, their spiral arms will twist and distort. Gas clouds will collide, triggering bursts of new star formation. Over time, the two galaxies will continue to move through one another, slowing down and eventually merging into a single, larger galaxy. Astronomers predict that the new galaxy may take on an elliptical shape and has been nicknamed Milkomeda, or Milkdromeda. The night sky on Earth, if Earth still exists then, would change dramatically. Instead of one soft band of stars, two glowing galaxies would appear in the sky, slowly drawing closer. Over millions of years, the view would shift as the galaxies combine, creating a brilliant, ever-changing display of stars. Although this event sounds dramatic, it will happen over a very long period. Each stage of the merger will unfold across hundreds of millions of years. If life still exists in the solar system or on any future world, it would witness a slow, cosmic dance rather than a sudden impact. The future of the solar system during this merger is uncertain. Gravity could gently move the Sun to a different position within the new galaxy. Some simulations suggest that the solar system may be pushed farther from the center, while others show it settling into a new orbit. In any case, the Sun would continue its journey, carrying its planets through the transformed galaxy. This upcoming merger is not unusual. Collisions and mergers are a natural part of galaxy evolution. Many galaxies we see in the universe today were formed from earlier mergers. The joining of the Milky Way and Andromeda is just one step in the ongoing life cycle of galaxies. Thinking about this event reminds us of the scale of time and space. The universe changes slowly, yet constantly. The Milky Way that we call home today will one day become something new, shaped by forces far beyond our control. As we continue, we will explore where the Milky Way sits within the vast universe, surrounded by countless other galaxies spread across space. The Milky Way is vast, but it is only one galaxy among many in the universe. To understand our true place in the cosmos, we must zoom out and look at the larger structure that surrounds us. When we do, we see that the Milky Way is part of a grand, interconnected web of galaxies stretching across space. The Milky Way belongs to a small neighborhood of galaxies known as the Local Group. This group contains more than 50 galaxies, most of them small dwarf galaxies. The two largest members are the Milky Way and the Andromeda Galaxy. A third large member, the Triangulum Galaxy, is smaller but still significant. The remaining galaxies are much smaller and orbit around the larger ones. The Local Group is not isolated. It is part of a larger structure called the Virgo supercluster. A supercluster is a giant collection of galaxy groups and clusters. The Virgo supercluster holds thousands of galaxies spread across a space roughly 110 million light-years wide. Even on this scale, galaxies are separated by enormous distances, but gravity links them together into a loose structure. In recent years, scientists discovered that the Virgo supercluster is itself part of an even larger structure called Laniakea. The name means immense heaven in Hawaiian. Laniakea stretches more than 500 million light-years and contains around 100,000 galaxies. It is a vast region in which galaxies flow along gravitational pathways, like leaves carried by gentle currents in a cosmic ocean. On an even grander scale, the universe is filled with billions, likely trillions, of galaxies. They are arranged in a cosmic web of filaments, clusters, and empty voids. Galaxies gather in long threads of stars and gas, forming patterns that stretch across hundreds of millions of light-years. Between these threads are enormous dark regions with few or no galaxies at all. The Milky Way is just one point in this vast cosmic web. From our position inside it, we see only a small part of the universe. Telescopes allow us to glimpse farther, but the full scale of the cosmos is beyond our direct view. The observable universe extends about 46 billion light-years in every direction, and beyond that, the universe may continue far outside what we can detect. Even though the Milky Way is one of countless galaxies, it is special to us because it is our home. It contains the Sun, Earth, and everything we know. Within its stars and clouds, life emerged and began to wonder about the universe. As we zoom out, our place in the universe may seem small, yet this perspective also brings a kind of peace. We are part of something vast and ancient, a universe that continues to expand and evolve. The Milky Way is one chapter in a story that stretches across time and space. As we continue, we will explore whether humanity might one day travel beyond the Milky Way, leaving our home galaxy to explore the wider universe that surrounds us.
For as long as humans have looked at the sky, we have wondered what lies beyond the horizon. Today, that horizon is no longer the edge of a sea or a continent. It is the boundary of our galaxy. The question of whether humanity will ever travel beyond the Milky Way invites us to imagine a journey far greater than any we have taken before. The Milky Way is enormous. Even traveling at the speed of light, it would take 100,000 years to cross from one side to the other. Our fastest spacecraft today would take millions of years to travel the same distance. Leaving the galaxy would require technology far beyond what we currently have. One challenge is distance. The space between galaxies is mostly empty and vast. The nearest large galaxy to us, Andromeda, is 2.5 million light-years away. To reach it, we would need a ship capable of sustaining life for countless generations or moving far faster than anything we can imagine today. Another challenge is energy. Traveling between galaxies would require enormous amounts of power. Scientists have proposed theoretical engines, such as fusion drives or antimatter engines, but these ideas remain in the realm of research and imagination. There are also ideas about using shortcuts through space, such as wormholes. A wormhole is a hypothetical tunnel that could connect distant points in the universe. If one existed and could be stabilized for travel, it might allow humanity to cross vast distances quickly. However, wormholes remain theoretical and unproven. Even if we cannot physically leave the Milky Way soon, we may still explore it through observation. Telescopes allow us to see galaxies far beyond our own, revealing the beauty and mystery of the universe without ever leaving Earth. Future telescopes may show us planets in other galaxies or signs of life beyond the Milky Way. It is also possible that life from the Milky Way could spread naturally. Some scientists think that microbes might travel between stars on comets or dust over millions of years. If life can move between stars, perhaps over much longer timescales, it could move between galaxies too. Humanity's ability to explore has always grown with time. Thousands of years ago, crossing an ocean seemed impossible. Today, we have walked on the moon and sent probes beyond the solar system. Our limits continue to expand as knowledge grows. For now, the Milky Way is our cosmic home. We are explorers at the beginning of our journey, learning about the universe one discovery at a time. The idea of leaving the galaxy reminds us of how much more there is to understand. As we continue, we will shift from the future of exploration to a more reflective perspective, imagining the galaxy as a single day and considering where we are in that grand timeline. The Milky Way has existed for billions of years, so long that it is difficult for the human mind to truly imagine. One way to understand this immense span of time is to shrink the entire history of the Milky Way into a single day, 24 hours. In this scale, each hour would represent hundreds of millions of years. By thinking time this way, we can see where we stand in the galaxy's long story. If the Milky Way formed at midnight, the first stars would appear in the early hours of the morning. These stars lit up the darkness of the young galaxy and began creating the heavier elements needed for planets and life. For much of this imagined day, the galaxy was shaping itself, forming stars, clusters, and spiral arms. Around 1 a.m., the oldest parts of the galaxy began to settle into place. By midday, around 12 p.m., the Milky Way's spiral structure was forming into the shape we recognize today. Stars continue to be born and die, enriching the galaxy with new elements. Our solar system would not appear until very late in the day. The sun formed at about 8 p.m., Earth appeared shortly after, and the first simple life began to grow in Earth's early oceans not long after that. For most of the remaining hours, life on Earth was microscopic and slow to change. Complex life did not appear until close to 11 p.m. Plants and animals began to fill the land and sea. Dinosaurs emerged only minutes before 11:40 p.m., ruled the planet for millions of years, and vanished around 11:59 p.m. with just seconds left before midnight. Humans entered the timeline at the very end of the day. If the entire history of the Milky Way were one day, modern humans would appear only in the last few seconds before midnight. All of recorded human history, from ancient civilizations to the present, would fit into less than 1 second. Seeing our place in this single-day timeline reveals how young humanity is. The galaxy has lived through an entire day, while we have been here for only a blink. This perspective can be humbling but also comforting. It shows that the universe has time to change, grow, and recover. The stars we see at night began their journeys long before humans existed. The challenges we experience as a species are brief compared to the long, steady rhythm of the cosmos. Thinking of the Milky Way as a single day helps us appreciate the preciousness of the present moment. We are living in a very recent chapter of a vast cosmic story, with most of that story still unfolding. As we continue, we will look at what the Milky Way can teach us about existence and impermanence, and how our brief moment fits within the endless flow of time. The Milky Way is more than a collection of stars, planets, gas, and dust. It is a reminder of the nature of existence itself. By observing the galaxy, we learn about change, connection, and the temporary but meaningful place we hold in the universe. Everything in the Milky Way is in motion. Stars are born, they shine, and eventually they fade. Galaxies grow, merge, and transform. Even the galaxy we call home will one day become something different. This constant change is not chaotic. It is the natural rhythm of the cosmos. The stars that light our night sky teach us about impermanence. Many of the stars we see are already in different stages of their lives. Some are young and bright, while others are nearing their end. Their light travels across space for thousands or millions of years before reaching us. We often see stars not as they are now, but as they once were. The night sky is a window into the past. The Milky Way also teaches us about connection. The elements that make up our bodies were formed inside ancient stars. We are literally made of stardust. This means that we are not separate from the galaxy. We are part of it. The same forces that shaped stars and planets shaped us as well. Life on Earth is brief compared to the galaxy's long history, yet it is precious. Our experiences, emotions, and stories unfold in a small moment of cosmic time, but they hold meaning for us and for those we share them with. The Milky Way reminds us that meaning does not depend on size or duration. Looking at the galaxy can bring a sense of peace. The vastness of the Milky Way shows that the universe is larger than any single worry or moment. It offers perspective, a gentle reminder that change is natural and that every phase of life is part of a greater cycle. The galaxy's quiet glow across the night sky invites reflection. It encourages us to pause, breathe, and simply exist, to feel the presence of time stretching behind and ahead of us, to remember that we are temporary, but not insignificant. As humanity learns more about the universe, our understanding deepens. Yet no matter how much we discover, there will always be mystery. The Milky Way invites us to embrace both knowledge and wonder. We can seek answers while still appreciating the beauty of the unknown. The story of the Milky Way is also our story. It is the story of creation, transformation, and possibility. We live within it, shaped by its past and carried toward its future. And in our brief moment beneath its stars, we have the chance to observe, to learn, and to feel connected to the vastness around us. By reflecting on the Milky Way, we come to understand that everything changes, everything is connected, and everything holds meaning. The galaxy shines above us as a gentle reminder of our place in the universe, a place both small and extraordinary.